My name is Patrick Coronado. I'm an engineer, and I work at the Applied Information Sciences branch at NASA-Goddard Space Flight Center. As an engineer, I work on various different types of science missions, one of which is the use of unmanned aerial vehicles, or very small little remote-controlled planes, and use them for science applications. My role in the Bolivia Project is to enable the scientists by providing them with tools, in this case a sophisticated remote control airplane, to acquire their science data. The reason this type of capability exists at Goddard is because the Earth Science Technology Office is supporting the design and development of technologies in the area of unmanned aerial vehicles. Now we have an opportunity where we can use these technologies, in this case in a mission to go to Bolivia and magnetically map a possible crater. The unmanned aerial vehicle, or very sophisticated remote control airplane, contains several electronic packages separated by a communications component, an autopilot which navigates the plane, a computer that collects the data, and the instruments. There's also a power plant that powers the vehicle across the air. So all those together allow the acquisition of the data, storage of the data, and relay of the science data back to the ground. The vehicle can go several thousand feet, but for this mission, again, it has some very unique requirements. It has to go as low as possible, but yet stay at a safe distance. In this case, we're planning on 200 to 300 feet in altitude. The way the unmanned aerial vehicle, or sophisticated remote control plane, knows where to go is by using a GPS, Global Positioning System, along with an autopilot and an attitude control unit on board the plane. Those three things control the plane's yaw, pitch, and roll, as well as direction by knowing the latitude and longitude of where it is and the latitude and longitude of where it should go. So it, in essence, flies a flight plan that has been predetermined on the ground. The data is collected by the science instrument on board. It is then connected to a computer which also collects the position of the plane. Both of these data sets are combined and then sent down, are stored on board and then sent down, relayed to the ground for safekeeping, just in case the plane doesn't quite make it back. Once the data has been acquired and offloaded from the plane or relayed to the ground, it will then be relayed to the internet via the Inmarsat-M communications satellite for immediate access by teachers and research scientists.